Everybody, welcome to Augusta. How you doing? It's great to be here. I'm James Stanger, and I'm going to be your host. I want to right away point out that the show is not the James show. It is the Keysight, Vectra, and Cribl show. Now, on screen, you probably can't. Hello, everybody, online. But if the three of you could stand up real quick for this group, real quick. These are the folks that are the show, as it were. Now, those of you who are here in person, see this QR code? If you click on that on your phone, you can join in on the online forum and see the questions that are being asked there online. So that way everybody's unified. Welcome online. How are you all doing? It's great to be here. Again, I'm James Stanger. As your host, I want to let you know there are some very important people here besides our friends from Keysight, Cribl, and Vectra AI. Other people include Ashoka. Ashoka, where are you? And Jackie. There's Ashoka and Jackie, who are fairly new CompTIA employees, folks. It's great to have you here. A person who's not a fairly new CompTIA employee is Stephen Schneider, who is moderating the online things. So everybody say hello, Stephen. Hello, Steve. Very good, very good. Now, what we're going to do, folks, is a couple of things. Today's event is being called, that's what I called it anyway, the Cybersecurity Viability Trifecta. How about that for a title, huh? Yeah. All right, I like it. Now, the reason I like it is because we have, again, three guests here. But the idea of visibility, observability, and you can't have a presentation these days unless you mention the term yes, AI. No, I was going to say upskilling, but we'll say AI just for you. So there's that. One of the things I want to do, folks, is just really quick. At CompTIA, we're an upskilling learning company, but we do a tremendous amount of research. I represent the research department at CompTIA, and I'm here to talk to you today about what we've seen in terms of industry standards. Over the years, I've been a company president. I've done work as a cybersecurity analyst, as a pen tester, et cetera. And it's been fun to do those sorts of things. Now, one of the things that's fun about it is that I'm lucky enough to talk to these experts. We have Brendan Wright from Keysight Technologies. We have Josh Brunewald from Cribl, and a repeat offender, Zach Vaughn. So Zach, it's great to have you here. Zach, is this your third time or second time? Third time. So I guess that's another trifecta. Seems to be a word I'm really interested in using these days. Now, folks from around the world, I'm going to bring you some research insights and things about what observability, what AI, what those terms mean and why they're so important. Today, folks, we're going to be talking about various elephants in the room. Elephants having to do with, what our job role is going to look like. How is AI really changing things? Is AI changing things, which it is? Will there be jobs in the future? What are they kind of going to look like? Now, none of us can tell the future, but I think what we can do is interpret trends. And those pictures, folks, are from folks that I've talked to around the world, CIOs in Singapore, folks in Africa who are IT workers. Let's see that lady down there. She works for the board of Coca-Cola. So we talk to people from various industry sectors, folks, not just the pure tech sector. And by tech sector, I'm talking like Silicon Valley, or as some people call Silicon Valley, but I think that's a different valley in California. I'm talking about sectors like healthcare, government, finance, manufacturing, shipping. So I'm lucky enough for CompTIA. Over the last 6 months, I've been on every continent but Antarctica. Stephen won't let me go to Antarctica. I don't know why. Probably because there are fewer people there. But so we're going to be talking about what it means to discover and analyze today's tech footprint using, let's say, AI, but traditional perspectives. And so that's one of the things that these three gentlemen are going to be on the hook for, is talking about this. What data collection really means in the attack lifecycle, the practical use of visibility and observability techniques, and what the difference is between those two. We're going to be talking about meeting today's challenges and things like that. Now, for those of you who are impatient, if you want, you can download the slides. There you go. There's a QR code. If you trust QR codes, you can download the slides. You might want to wait to actually download them because I've unified. No, you're fine. You can. I just uploaded the new ones. So go ahead and grab those all you want. okay? So there's that. And again, I'll make that available at the end of the presentation as well. But I just wanted to give people a chance that you can get the slides there. So now before we go any further, I want to encourage interaction with us. And by us, I mean our esteemed panel, but also me. And the way I like to encourage that is by doing what I call the Stanger selfie. Has anybody here been on one of my presentations before? Then that means you've had your picture taken by me. So if y'all could stand up. Did I do a y'all okay? Is that good for Augusta? If you all could stand up. And by the way, online, jstanger@comptia.org. JSTANGER@comptia.org. Send me a selfie, okay? So everybody, I'm going to take the selfie from here. So if you guys could all kind of scoot together, because I don't have a camera that's this wide. See, I've got to prove to my boss that I actually did show up at Augusta. It's beginning to wonder, it's like, does he really go to these things? All right, so let's see if we could all join in. I think we're more or less all there. Everybody on three, we'll say CompTIA on three, fair enough? After three, 1, 2, 3. CompTIA. Thank you, folks. I'll post that up on LinkedIn. You can join me on LinkedIn. I'm James Stanger. Some people call me James Stranger. That's fine. I can live with it. Some people call me James Strange, and I take kind of personal umbrage at that, but that's okay. Relevant cybersecurity paradigms. Some of the things that I think, hey, come on in, guys, have a seat. Now, first of all, I want to stop and ask right now, does anybody have any particular questions right now? I'm sure you're thinking, well, James, you haven't really begun the presentation yet, but I'm curious what questions you have. And those of you who do have questions, I think, Stephen, we've got a microphone hanging around somewhere. Make sure you talk into some sort of microphone so that everybody here can hear you and also all the folks online. So if anybody has any questions that you would like to ask the panel, the way this is going to work, folks, is we are going to first be having presentations, one by me, and then one by each of the three gentlemen here. And then the second hour will be a panel. Fair enough? So the first hour talks, second hour panel. All right? Well, let's talk about some relevant cybersecurity paradigms. You know, at CompTIA, we do a tremendous amount of research, and we publish it. It's for free. You can go up online, CompTIA.org, and check it out. One of the reports we have is called the Workforce and Learning Report. Comes out every year. One of our second reports is called the CompTIA 2025 State of Cybersecurity Report. That comes out every year. But one of the things that came out, if you look at these 5 different elements that came out first, is the pace of tech change keeps coming, is getting faster all of the time, and I think that's a big deal. But the fourth one, I think, is the interesting one, particularly to this particular session. Human AI interactions are challenging legacy approaches, and today we're going to be hearing about legacy and new cutting-edge approaches to things. So one of the things I think is really important, because there's plenty of opportunity out there for what I call, and that's is a term I've stolen, creative destruction for job roles and job skills. In other words, creative destruction. AI is going to create things, AI is going to take things away. My favorite analogy, and maybe you have a better one, blacksmiths in 1900. How many blacksmiths in 1900 were there versus blacksmiths in 1920? In 20 years, there weren't that many. There weren't as many. So in a period of from 20 to 30 years, there went from being blacksmiths everywhere to being not so few. Well, guess what happened? Mechanics replaced them. Most of those blacksmiths either retired or they became excellent mechanics because they knew how stuff worked. And those older ones probably had the ability to go, hey, I don't have that part for that car, but I can make you one. As opposed to a newer mechanic who's like, well, if it's not coming from the factory, what are we going to do? I use this as an analogy, folks, because when it comes to understanding how AI is changing things, hi, Sandra, how you doing? When you look at things about how things are changing things, check out this is some research that we got from our State of Cybersecurity 2025 report. The use cases that seem to be the most interesting are along the lines of using AI to improve internal operations and kind of defending against AI threats, obviously, and then internal and external efforts. But the specifics are what interest me. Monitoring, check it out. See that there? Monitoring, generating defense tests. So we're really kind of talking about 2 different ideas here. Generating defense tests and then predicting future breaches. You're going to see in the future presentations coming from these 3 gentlemen. they'll be talking about how AI helps statistical kind of approaches, but also informational approaches. Statistical meaning, well, let's take a look at what we're seeing based on the numbers. Others come from threat intelligence. And how can AI help both statistics and that? There's also the idea of automating incident response, which I find really interesting. Because traditionally, automating incident response has generally been something that is kind of frowned upon. Because it's like, well, I need to understand the context before we do automagic things. Because I remember early on, 30 years ago, when I was learning 35 years ago about cybersecurity, I said, well, why don't you have a script change that firewall rule? And he said, well, James, I don't want a script doing that because that might be the wrong decision that I've made 2 years ago to put that script in place in case a certain condition arrives. Maybe that condition is not what I was thinking of. Maybe things have changed. So with the advent of AI, can we do intelligent automagic incident response to analyze user behavior and automating infrastructure? And that's interesting to me. Automation, I think, is really what's going to change things. So it's all about unique skills combinations. Whether we talk about cyber ranges or cybersecurity certification or what have you, to me, it has to do with finding ways that AI will influence these areas, but also finding ways that you get the right skills in these specific areas. And check out the things that bubble to the top. Network and infrastructure security. So we're talking about critical infrastructure. Notice the threat landscapes, or attack surface, as it were. Now, threat landscape, yeah, I'll call it the attack surface. Application security. If AI is changing workflows, and that's a fancy way of saying, well, every day I wake up and I do certain things to create code or to implement something in the cloud or what have you. That's a workflow. And I think application and data and endpoint, those are all part of transforming what workflows are. The biggest thing that we're seeing in the industry, whether it be cybersecurity oriented or IT oriented or even just how a business works or how a department works or a division works, is how do we best figure out how to interact with AI? So I can't help but think of a trifecta here: visibility, automation, and communication. Visibility is the what? Conmon. Anybody heard that term before? Conmon? Am I using it correctly? The idea of constant monitoring. So we're talking about the idea, if you're going to do zero trust, you have to have continual monitoring because you don't know if that process has been taken over from moment to moment by a bad person, for example, or that endpoint or what have you, or that person, for example. But communication. But I would argue there might even be a quad here of observability, and there is. It's the idea of more than just getting data or looking at packets and things. It's understanding workflows, the so what. So if there is some sort of process that is taking place from applications or with data, or with an overall AI solution, there's something along the lines of how can we observe how one affected entity, whether it be something like a router or a firewall or an endpoint, if something is affected, how can we see how that affects other elements of it? So you're going to be of an entire process. That's my attempt to talk about the idea that with observability, you're correlating more than just the state of a network or of applications. You're correlating the entire way that a business responds to certain events. And that's a big deal. It changes things. Now, here's some considerations. We can't just keep increasing the cost and complexity. Okay, I can solve that problem for you, but I can only do it if you give me tons more money. Generally, there isn't more money. And generally, there aren't more individuals available. And I think it really comes down to this. We have to understand that certain capabilities are becoming more common. Fancy word, democratization. Defrictioning is a word lately that I've heard a lot. When it comes to AI, how do you guys use AI? Anybody here use AI in the place of Google? You used to go to do a Google search, now you go and use AI to do a search. Is that fair enough? How many of you are using it as a co-pilot for meetings? I don't want to I've attended that 1 hour meeting. I don't want to read another hour log of that meeting. I'll have AI create a 5-minute summary. Fair enough? These are all ways of defrictioning things. But also, when it comes to AI implementing things, a lot of people, as a pen tester, for example, I've used AI to create scripts for me. Now, I had to fix it. But it saved me time. See, that's defrictioning because it just allows me to get stuff done faster. I guess my question to you is, as we defriction things, are we able to defriction things wisely? Or are we simply saying, oh, it doesn't matter how good that Python code is, let's just implement it in our tech stack and move on? That can be a bit of a problem. And have you ever noticed that when it comes to defrictioning things or removing the barrier to entry to a process, it's always somebody else's job role that gets defrictioned and not mine? I find that interesting. So I think there are things to be thinking about in terms of what you're going to be hearing from these three gentlemen. I think we need to figure out better how to extract the signal, the truly important information from the random data. And that's what you're going to be hearing about all these organizations, how they do that. There are two methods that a lot of these things are done. There's the mathematical, looking for anomalies. There's research and threat modeling. I think you'll be seeing some interesting ways in which that's done. And it really comes down to understanding how these days, as cybersecurity professionals, if you are to stay ahead of AI, it's more about curation than it is collection. And curation's a pretty big deal. Let's put it this way. If you work for a museum, you get paid more as a curator than you do as a janitor, okay? The reason being is one kind of collects stuff, the other one interprets stuff. So it's all about important combinations. Last year, I was at the Billington event, a Washington, D.C. event, and the phrase toxic combinations came up. It was from a Microsoft person saying, we as cybersecurity professionals look for toxic combinations. And I love that term because it allows us to apply X-factor skills to come up with interesting, unique solutions to identify those combinations and then fix them. So where does AI fit in with that? And you're going to hear from Keysight, Vectra AI, and Cribl exactly how they go about kind of going beyond the mere eyes on glass. You ever heard that term, eyes on glass? How can we go beyond that to true observability? So whether it be the Lockheed Martin cybersecurity kill chain, the MITRE attack model, the Diamond model, these are all models that are used increasingly to help understand the tactics, techniques, and procedures of attackers. I think it's really interesting to see the toxic combinations that can happen as one technology meets another. And by that, I mean as a person's brain connects with AI, or as AI connects with more AI, or as an API connects to a client connects with an endpoint, or a web server to a SQL server. Where are those spaces, those hard to reach places, as it were, where attackers love to manipulate? I think some of you may have heard this, but I love to use this example. I took this picture in Teton National Forest here about 4 or 5 years, 3 or 4 years ago. Anybody see anything in the middle of that picture that's kind of unique? If you look right in the middle of that picture, you'll see a grizzly bear. We were hiking along and my son said, "Dad, there's a grizzly bear eating right over there." And they all hightailed it back to the car like you're supposed to. I ran towards her and got that picture because it was just fascinating to me to look at this. I don't know who the threat actor was, if it was me or the grizzly bear. But the reason I bring this up is when it comes to understanding the forest for the trees, how can these folks help you use AI to understand the threat actor happening in there? And by the way, I love my analogies. And one of the analogies I saw here was, notice I don't know if you can tell from here, but there's a bunch of trees that are distressed there. Can you see a lot of them are dead and standing up? Many of them fell down. She was scraping the bark off the bugs, and she was eating the bugs out of the bark, right? I couldn't help but think of a threat actor invading, as it were, a forest, as it were, but also a bunch of hosts and living off of the bugs from distressed resources. That's what hackers do. That's what attackers do. So how can we find that? And the answer is looking for patterns. You're looking at something called RASH. You're looking at a series of, I think it's 5, R-A-S-H, 4 volcanoes: Mount Rainier, Mount Adams, Mount St. Helens, and Mount Hood. You can't see them all clearly, but you will when you download the slides. The reason I like this slide is, as a Pacific Northwesterner, it rains a lot. And if you're in a plane and you're lucky enough to see sun and those 4 mountains all at the same time, you'll say, hey, I saw rash. See, we understand our patterns on some level. So what, in some ways, can AI help us understand patterns in business workflows? to provide context, to get data. We all know that data feeds AI, that's fine. But what we're gonna hear about in the upcoming presentations is how all of these things work. And by the way, I mean by business workflows, I'm talking about how software is created. We know that a lot of issues can be created when software is implemented. We all know that the life cycle of data is a big deal to understand. So what does it mean to be authentic and organic in an AI-augmented environment? Well, we move, I think, from the traditional understanding of the CIA triad, confidentiality, integrity, and availability. Maybe we look at new things, correlation and information and aggregation. We become collectors and contextualizers of information. I think increasingly with the help of AI, we can understand what it means to implement real curation, to understand the different architectures that are around. Business, application, data, and technical architectures. This is from our 2025 report. And those are insights that we gain not only from hundreds of CIOs around the world, but these are some people, I got a lot of those insights from, for example, those people, that guy with the beard there, he is the CIO for Cambridge University. Also got that insight from a bunch of security analysts down in Jakarta. Over in Jakarta. So what does it mean to actually say, well, we can look at packet captures here. And if you look at that red there, you'll see that's basically somebody's been using, it was me, using ICMP to steal data from one company to another. Well, so what does it mean to curate that data? What are some of the skills? This is me, I took that same packet capture, I uploaded it into ChatGPT and started asking it some questions. And you know what? ChatGPT was able to come up with some good answers. You'll notice right away, it noticed there's the passwords that were stolen. ChatGPT was able to do that. I was able to give this report and show this to a couple of people. There were some security analysts standing next to me and also the CEO of the company. And the CEO went, James, this is kind of interesting. What do I need security analysts for if ChatGPT can do this? And the security analyst kind of looked at me and were kind of like, gee, Stanger, thanks. I appreciate the help here. You just, everything I do is not important. And so I said, hey, CEO, why don't you sit down? Sit down and check it out. And the CEO sat down and he goes, okay, what do I do next? And I said, well, what do you mean? He said, well, what do I type into, what questions do I ask ChatGPT? And that's when I said, ask these guys, they know. My point here is not that ChatGPT is useless or that security analysts are useless, it's the interaction. And it's also the ability to get C-level people to understand, or upper level people, whatever you want, to understand what it means to properly interact with AI and how to use it. Because we are definitely doing curation here, folks. You're looking at something that is something called Security Onion. It's a SIM tool. It's an open source one. You might know Splunk or QRadar, or any of the others that are out there, RSA, Security Analytics, all those. The key here really, folks, is understanding what it means to do proper curation. And I'll kind of end here with an example. Anybody ever heard of slop squatting before? All right, you have Vectra. Anybody else heard of slop squatting? Slop squatting is a form of typo squatting. You know what typo squatting is? If there's a Google URL, like Google, if you do G0OOLE, right, and you register that and that becomes your domain, that's typo squatting. Slop squatting is this. I'll start with a silly example and then more sublime one. A friend of mine had has a daughter who, as a student, she was creating a research paper. And guess what? She asked ChatGPT to help, create the research paper, and of course it did. And it came up with resources, came up with the references cited, okay? Which is fine, a bibliography. Well, guess what? It made up 2 or 3 of those out of whole cloth. The teacher went to the websites and they didn't exist. Not just the pages didn't exist, but the entire website. Because ChatGPT knew it would be asked, where'd you get this information from? And it hallucinated, you could use that word, I guess. It made up some resources. What does that have to do with anything? Well, you do realize the same thing happens in coding, don't you? When it comes to coding, there are situations where if a coder says, hey, I need you to make me a Python script, a sophisticated one, well, it will come up with the coding and it will say, and here are some of the libraries that can be used to supplement that code and make it even more powerful. Happens all the time in coding. Well, guess what? In many cases with slop squatting, what happens is the code that ChatGPT created, or Claude, or I don't want to pick on any one of these Gen AI tools, created a fictional repository. It was a GitHub repository. Didn't exist. If you're an attacker, what would you do in that case? If you knew that person A created some code with the help of ChatGPT and created that, and then there was a fake repository there, what would you do? If you're an attacker, you'd create that GitHub repository. You'd put functionality in that made that code work. And then you'd put in all sorts of wonderful supply chain sorts of backdoors and all sorts of bad code in there. Happens more than you'd care to think. If people are not sophisticated in there. So slop squatting is simply this. Somebody gets sloppy creating their resource, their code or their research paper, and then somebody comes in and goes, okay, I see there's a resource there that doesn't really exist. I'm going to substitute something there. That's how you come up with supply chain attacks. Is vibe coding bad or good? Ideation's always good. But if that vibe code, like always happens, I shouldn't say always, often happens in Silicon Valley environments, ends up in the production without being properly vetted, yeah, you've got problems like slop squatting and things like that. I bring these examples up, folks, because these three folks are going to be here talking about their solutions to try to solve some of these problems. I'll end with this. I like to talk about different job roles. This is a job role that's been discussed for a better part of a decade, but it's the idea of the forward deployed field engineer, kind of a controversial kind of idea. If you ask me, they're kind of referring to an on-site consultant. But it's the idea that somebody brings in some software engineer, some platform engineer. By platform, I mean Salesforce.com. Or some sort of cloud-based tool. And then they kind of understand their solutions and how to create that. That could be a cybersecurity side of things. I think it's somebody who has these types of skills. Software engineer, they know customer workflows. They know how customer, whether it be your division, whether if you're a contractor, what they need. And then you can use various solutions and put them in place. Just an example of one of the job roles that you'll hear about, but I think more and more we need specific knowledge. People understand, let's say, software engineering. They know customer workflows and then how to automate properly when it comes to cybersecurity. So there are some things there. I think, again, when it comes to defrictionalization, the idea, folks, is that AI can do the work of 10. Does that mean we eliminate those 10 workers, or does it just mean we make them more productive? Now, in the United States, a lot of leaders of companies, especially in certain sectors, Silicon Valley, they would tend to say, well, it replaces workers. But around the world, in Europe, they don't look at it that way. They look at it as a way to automate and make things a little more easy. In Japan, lately, when I was there, they talked about it improving cybersecurity, but also improving customer experience. So I think it's really important when we defrictionalize that we don't engage in fiction, okay? Now, these folks are going to be talking to you about real life things. One thing I want to point out, you are, many of you, network security experts. You know, data, things like that. We have a network of experts that we'd love to have you join in on. There is a QR code if you're interested in becoming part of this network of experts, where you basically will help us shape products and things like that. We'd love to get your input. There's a QR code there, so thank you for connecting that way. And if you downloaded the slides here, you'll see this later. You could use the QR code later. So again, we have tons of research, from the state of cybersecurity to building AI strategy to our industry outlook report. So there you have it. There's my LinkedIn profile. If you want to join with me on LinkedIn, I'm James Stanger. You can go ahead and do that. So let's go ahead now and hear from our first set of solution providers, Keysight. So let's give a great big hand here. Give yourself a big introduction and we'll go from there. Absolutely. Thanks, everyone.
All right. Well, thank you very much, James, for the intro, and thank you, CompTIA, for the opportunity to be here today. I am Brennan Wright. I am a solutions architect. I cover mostly federal teams here at Keysight. Keysight is a very broad portfolio provider, so we're known to a lot of different people by a lot of different solutions and focus areas. What I want to do, and something that I've really tasked myself with, and a lot of others at Keysight have as well, is look at things from the lens of a company that's been around since the early days of HP, but looking into AI as far as kind of introspective, as well as out to what is going to impact our day-to-day, which is our customers actually implementing things. So to kind of start from there, I took the first look at it and got to understanding where we're seeing this. And again, I'm targeted mostly federal, which works well for the cause here today. But AI is already here, and it's been here, right? So there are some really good examples at various institutions and Library of Congress and folks like that have been using what falls under that large umbrella of AI, which is a collection of hundreds at this point of different technologies and thought processes of AI. But from a generative AI, from the kind of modern understanding of what it is, and from that broader impact of things other than just kind of a simple computer vision, I keep seeing time and time again, and I fit the big three on here so it wouldn't become an eye chart. But from running around the DC area, seeing the various conferences and various people talking, it's been here and it's been active in about the last year at an enterprise level. Right? So actually meeting the field, working its way towards a war fighter, definitely at our agencies doing various tasks. We're seeing it from a couple of different places. A lot of it is homegrown. You know, there might be some contracts focused on specific use cases, but we are also seeing the enterprise influence of full canned solutions and platforms coming in, right? Kind of get bootstrapped up to AI. Because a lot of our leaders are going to conferences like this hearing AI, and we are right back where we were about 12 years ago with the cloud influence, where everybody was coming back from the conference and saying cloud means three major things, right? Less people, more productivity, and it's all going to be done cheaper, right? So everything needs to have cloud or it's not going to get purchased. I think we're kind of at that state now where if it doesn't say AI, don't buy it, because we don't know what it's going to do yet. But that means something very different in most cases and is causing a little bit of issues there. But it's very promising, which is, I think, what the allure is. There have been some really good published from the Office of CIO and a lot of other entities, and of course the DoD, entire lists of the use cases that can be targeted, not to mention the ones that have already gotten started. When I started kind of doing the discovery to see where all of these different use cases are at, I actually found, especially at the Department of State, some clear references to AI-related work projects that had actually just closed out in the sunset. Right? So it had gotten conceived 2 years ago, went into production a little over a year ago, and got all of the data set that it needed, resolved what the goal of the project was, and then wound down. So we're already here, right? Like we're all here thinking AI is something coming, but the reality of it is at an enterprise level, it's already being influencing. And it's also something that is just going to keep spiraling because there's just so much that we can do with various things. I picked a couple of my big deployment considerations that matched the big trifecta that we're trying to focus on here today. I can get a little bit scattered and go running off after different concepts. So these were the big three that I kind of wanted to touch on. Some of the big considerations is around things like the system governance and security nature of the AI platforms, right? Nobody wants to approve a multi-million-dollar purchase or a big implementation project and then have the new ground rules come out that invalidate that entire solution just because of some component that breached a security requirement or governance rule. And then, of course, we've got our data security. That is bigger and better, especially as we start to get to things that influence lives and real processes and real products. That data has been something that's pushed to the cloud quite a bit. However, not all of it has. And depending on what it's working on it and the output of an AI system, there is some real security challenge around where that goes to or who might get access to all the back-end data through those systems. So there's a lot of different challenges in that I think people are interested in, and there's a number of startups already targeting that. Another one that we might have here is performance. So especially in the case of the like state chat is a really good example, and some of these other here that are already hitting line personnel and are already starting to impact our work processes is the performance of it. Right? We're right there at that early stage where the proof of concept is kind of in whether or not people actually utilize it as it goes forward. And at that point, it starts to impact our ability and our readiness and our work productivity. So performance starts to become a much bigger consideration than it is in the early days of, wouldn't it be great if we could have it look at medical scans and things like that, for instance. So some really cool examples that I saw floated around are, patent approval verification and some of those kind of things as parts of the overall process before things get included in the Library of Congress, next to upload, next to scan kind of processes. They've gotten very good at figuring out what makes sense where, because there's a lot of this human in the loop conversation from there. But if that part of the system takes minutes to come back with a response and it starts to slow down your automation, now you've got a real performance issue, which you need to know about as you start to scale these applications like any other traditional enterprise style app. One of the last things about it is where exactly these things are. So this whole idea of everything being started in the cloud, we're kind of at the other end of the pendulum swing in a few years, I think. We're starting to work our way back towards needing things at the edge. Edge processing has been a big conversation. I know tactical edge is a conversation that continues to come up and grow for a lot of these other considerations, right? If it's happening in your premises, if it's happening closer to the warfighter, for instance, you're a lot less susceptible to telecommunications issues, to jamming, to outside influences, to somebody being able to access something in somebody else's system. And then, of course, at the final leg of it, with all of that impact, the performance of it, right? That's great that it can define and it can detect specific type of weapon systems on specific things in a very grainy image. But if it can't do it in the middle of a hailstorm in the middle of South Africa on a very hot, bad day when the weather just flips on you, then you've got a performance issue. So it needs to be able to scale, but also do that at an edge. And then, of course, all of this comes back around to something that, from the enterprise side of us pushing out solutions, has always been a part of it, right? We learned the hard way decades and decades ago that it's about the life cycle, right? You can't just put switches into action. You can't just go buy a new off-the-shelf email server, right? These things take forever to decommission when you go to replace them later. You have to consider all of the maintenance and overhead and monitoring and replacement planning for all of these systems as they go into place. It is something largely that's being missed in AI application development because we're very excited about the use case, and a lot of these things are being driven by the data analyst side of our operations, right? The people that are trying to get some intelligence out of things, the people that have the data source that's being worked on, the people with that processing involved. That lifecycle management is just what you do in network engineering. It's what you do in large-scale application engineering. It is what you do in an AI influence or AI component app in the big complex systems as well, but it's not necessarily something that we've started to see the error of until many of these systems start to go live. There's a number of different concerns, right, that I already highlighted here. Security is just a good example one. What I mean by security in an AI sense is not just the traditional infrastructure security, because there is a lot of that, right? We can't get rid of that. There's a lot of our boundary systems that have changed. There are a lot of things that have changed in the security world in general. But AI is an application front when we start to think generative AI and AI-enabled apps and multimodal AI components and things that interact with processes, they have application level components to concern ourselves with. And that's a different threat landscape than was there before. A lot of the research on this and a lot of the thought providers from folks like Vectra have started to be published over the last few years, and that's starting to kind of coalesce around some different threat vectors to keep an eye on. Many of them influenced by the underlying infrastructures, which is the world we come from. Here at Keysight, but it is something that is now very much in a native application sense different than some of our traditional apps would have been. It's just a very small list that started to come out. Little spin there of all of the different things that are very AI specific now that we all need to go relearn on and or work with newer solutions to help focus in newer ways to guide ourselves toward. So the big angle that I want to kind of talk through on our side is really part of our specialty, right? We are a test and measurement company and a network visibility area to it as well. So from a platform visibility perspective is really where our background is, right? We were all about getting all of the flows, all of the records, all of the packets from all of the places, enabling things like zero trust. When we look at that from an AI infrastructure, though, it's a different type of infrastructure. But we're right where we were about 12 years ago with cloud, where all of our leadership draws the pretty diagram. That's why I kind of included the little cloud icon here. That's the platform, right? That's the thing we're buying off the shelf, where they're coming in and they're building out the system. And we're a little surprised when it says Dell, HP, Lenovo, et cetera on it, right? Because At the end of it, we thought it was a brand new thing, but at the surface of it, when we start to peel that back, that infrastructure component has to have some sort of an infrastructure. So it's compute, it's networking, it's storage, it's those basic operational tenets that still do need to be covered. The big twist that we start to see there is a lot more GPU that didn't used to exist at the edge or in the data center environments. A lot of that, again, that compute resource starts to push things more again to the edge, back on premise, where we don't need to work on or rely on all that outside interconnectivity to ensure our operations. On top of that, of course, is the platform itself. So this is what I've now seen a couple of different good examples of this, of startups focusing on deploying, right? So when you say, I want an AI search app that works on my data, right? They can bring you the whole thing. That's mostly going to be fairly standardized architecture systems with their secret sauce, which is that container platform. Largely, like in most modern applications, we're talking about containerization, right? At minimum, there's some virtualization to get some things collapsed down onto discrete hardware, start to abstract it a little so we don't need to worry about what platform we're on physically. But containerization becomes very powerful from a scaling perspective as well as from the ability to interface all these different subcomponents that can be wildly different. On top of that, in an AI environment, so as part of my research, I built, and I'll talk about this a little bit later, a functional AI app utilizing just open source components. So I went out and found a web front end that would act as a ChatGPT type interface, chat with the different agentic systems, or just an LLM. I went and found something that virtualized LLMs, a little Ollama, a Docker container that lets you load up, interface, and work with GPU very easily. And then I had my data store, traditional data, right? I fed it some of our data sheets from some of the products we sell. And then, of course, we get into the AI-specific things where they deal in different types of data storage, something called vector databases. And then, of course, on top of that, there's ML libraries to do some computer vision and maybe some text translation, things like that, right? So once we start to put all of this together, what the user is presented with is what is that cloud icon, right? Somebody brought in a box, put on top of it a bunch of software, and I've got a web interface that then lets me point it at my data stores, lets it do decisions for me, lets it do things, including interact with external generative AI systems or public APIs that it calls in to extend. All great stuff that previously we would have been able to get access to somewhere near the edge, right? So as users interact with that whole nightmare of a system now, we're able to get access to every one of their flows and interactions as it passes out from the system. But what we've got to be careful with is that internal to the platform system. That, as we kind of go back to that rear slide of AI-specific application level threat mapping, requires more granular visibility, right? We need all of the packets, including everything that's intercontainer, all of this intercommunication above that platform layer that is spawned by my user making a query. So in a system like the one that I set up to kind of demonstrate these things, all we would see is that web request to a front end, right? Maybe authorization, the user sends a request in, if we're doing our job and we're decrypting and we're seeing that whole flow. All of the resulting traffic after the fact is invisible to us, including everything that hallucinatory AI LLM called for and had access to and went out and reached for and rewrote those types of activities, including the existence of which LLMs are under the hood, right? Because I'm just making a front-end web application or an app from a phone call. How am I going to know that it's DeepSeek and that that's Chinese materials that are involved and that that's not allowed on our network? And all of this being so modular, it changes constantly. So every update I get from that platform vendor may include half a dozen different versions, iterations, or containers. So the idea here is that we're able to get into all of those environments as well and capture that east-west traffic and include that in the AI model identifications, traffic identification, and pass that on down the line to our very important partners that can then make the real assumptions off of that, now train real AI detection systems off of that, and understand what's happening with the full picture, as opposed to that very narrow external-only traffic. We have made a number of announcements. There's a number of things that I won't talk to because those are road mapping. We could definitely sign up some later discussions around that. But from our public facing, we are that packet capture and delivery system, right? We make sure that we get all of that traffic from all of the AI places and all of the backend environments. We have the ability to do things like decryption, dedupe, those types of things that help our partner vendors excel at what they do, which is going to actually make the detections, actually make the inferences off of all of that data that we pull together. The importance of decryption, of course, is hard to underestimate, especially within the AI apps. All of these containers can communicate on encrypted ports and have their own SSL libraries that they're using, their own encryption languages, especially as we get into things like TLS 1.3, we get an increasing level of security there that will break things if we try to do traditional or post decryption as opposed to participating in the line or grabbing the traffic before it's encrypted. If we don't get that decryption to our partner vendors, they're going to have a lot harder of a time detecting the actual application level threats that we talked about before. So those AI level ones where something got malformed, something got hallucinated, something went to something external that it wasn't supposed to, those types of flows need to be decrypted to be fully understood by a defense tool. Here's a good example of how it actually works in practice. We can deploy agent taps sensors via containers, installers, physical taps on different links and legs, and we could do that at very large scale into the terabits, the large data centers, the edge environments. We can write on deployment chassis to go out into the field, do all sorts of things like that with the goal of getting every one of those packets and then sending it one time to a sensor like Vectra AI, for instance. AI detection can then happen after the fact or during. We have the ability to, since we're doing the decryption, we're already kind of seeing the flows in traffic, send a specific sensor, specific traffic from the internal environment. So we can detect that Gemini, for instance, is being called for, that there might be something like DeepSeek involved, that kind of thing. And then you can decide which tool vendor gets which traffic based on that, if that's of use. We also do have one announcement that I am allowed to talk to because that did already get out and fully published. But we've started a new tool called Application Fusion, and that product group works with a number of our active partners right now in our ecosystem where they're actually able to deploy their AI sensors directly onto edge networking packet brokers. So as flows are coming across those environments, including environments that might incorporate SSL decryption, getting all of the weird edge packets, those sensors can just deploy on that. Again, we're just trying to reduce the scale that you need to hit that edge environment and then increase the visibility by getting things and sensors everywhere we can. Last but not least, this is probably my favorite part since I've spent a couple of good weeks on this, but the local lab AI. So in order to really understand how a lot of this worked, to show it off to my coworkers and to some of the partner vendors and to really prove out some of the technologies that we bring to the table, right? That visibility in weird, hard to get places, the decryption, and then ultimately the generation of additional traffic or security threats within it. All of that, I built a simulation environment. And to do that quickly and easily, I pulled as much open source as I could using Kubernetes automation and some Helm charts and things like that, and a script that just sets up an Ubuntu server to run that locally as a single node Kubernetes cluster. So ultimately at github.com, Brennan Wright, local AI lab. I'm looking for some good feedback now. I've gotten a couple of internal folks that have been able to get this up and running. Definitely reach out. I've got some contact information in there as well. If you're interested in any of the trial licenses or have existing licenses and just need copies to be able to do the traffic generation into that lab as well as the tapping out of it. And if that's not what excites you, at minimum, this gets the K8s environment up, just Kubernetes shortened, with this full stack on there where you've got something to automate it with, a web front end, an LLM launcher, and it can use just whatever local GPU resources are there to make it actually work. So some fun to play with, some food for thoughts, and hopefully some environments to break, attack, and prove out all the good things. Do you want me to pass it back to you?
Yeah, well,
fantastic. All right.
Sorry, I'm making a presentation. Folks online or in person, did you notice some key words here? I noticed things such as Kubernetes and orchestration, GitHub, things like that, in terms of skill sets to be thinking about. I can't help but think of the narrative these days of the border and Golden Dome. You guys know what I mean by Golden Dome? Right? How that all fits in. Well, it does, because automation is a major key of it, a key there. So next, we're going to be hearing from Mr. Zach Vaughn from Vectra AI. Zach, everybody give Zach a great big hand.
Thanks, James, and thanks, Brennan. Excellent. Yeah, appreciate you all taking the time to be with us this afternoon. Unfortunately, I'm going to outline a number of problems, some of which James had already touched upon, some maybe you've already been thinking about. But we're going to break the session down in a couple of subsegments and try and keep it interactive, so please feel free to stop me at any time if anything doesn't make sense. But just start with a couple of quick surveys. Does anybody have any idea as to how these four sets of figures relate to one another? And there is one right answer. I'm not going to say there are any wrong answers. So not to bury the lead, but 2 billion is roughly the number of events generated on even a moderately sized DoD network in a given day. The number of events. An event can be, use your imagination, but 2 billion events generated on any given network in a given day. The second number, the 504,307, is the number of open cybersecurity positions in the US, specifically supporting federal agencies and their adjacent agencies at the end of last year. If we think about the correlation between those two figures, the number of events, the number of adversarial behaviors that are being launched against our critical infrastructure, against the supporting systems, and then you think about the number of people that are there, frankly, the number of people who aren't there, to me, that's chilling. And we'll talk a little bit about how that can be addressed here in a little bit. That third number, the percentage, 74% of polled analysts at the end of last year said the previous 3 years has been the worst time in their career in terms of being a cybersecurity analyst and incident responder, just in terms of the amount of data that they're being asked to meaningfully interact with, the burnout that they're experiencing because of that deluge of data, and just the pace at which they're having to try and fend off these evolving cyber threats. Lastly, $8 trillion, and these are not my numbers, this is actually from a published survey here. $8 trillion is roughly the amount of capital damage, if you want to call it that, experienced worldwide at the end of 2024 as a result of cyber attacks. From a federal perspective, specifically from a DoD perspective, I don't know that you can necessarily quantify things in dollar amounts, but if we look at potential harm to the warfighter, to our citizens, to the systems here at home, that has a monetary value, but frankly, what's at stake is the freedom and way of life meant to be protected here within the United States. So James had kind of already touched on this in a different context about who's using AI. Who here, if you're able to share, is using defensive AI-enabled capabilities in terms of defending your networks, your perimeter? Fair enough. Who here thinks that the adversaries that are attempting to gain a foothold within your environments are using AI? Okay, about a little bit more than half the room. I had to send these slides, or I didn't have to, but I sent these slides before I came across a very recently released toolkit. I'd suggest everybody go out and look at Hex Strike AI. Basically, it's one of the first published frameworks that allows for, I think it's roughly 70 offensive security tools to then be plugged into systems like ChatGPT, Claude, what have you. It's meant for offensive security testing. It's already been forked and is being turned around and being used for nefarious purposes. So when we talk about the imbalance there, right, of the number of attacks that are being launched at us regularly, now think about the ability to spin up these fully automated systems that can mix and match these different toolkits to continue to probe. The old adage is, we have to be right 100% of the time. An attacker only has to be right once. And now they have these types of generative AI capabilities, building for them out of whole cloth, new attack frame, or modifications of existing attack frameworks. The amount of signal, the amount of noise to the actionable signal just continues to go pear-shaped. So I guess I already started talking about some problems. We'll continue to talk about problems. So ultimately, you could kind of reduce this down to a problem of the amount of data that you're being confronted with and to meaningfully interact with, the amount of time you have available to you in which to meaningfully interact with that data. You can also flip time around and say, how long did it take you to come to the data that was most important to what you were trying to uncover? And then, what is the cost of that, whether in terms of what we're talking about in terms of full-time employees, the potential harm represented or cost representing that harm. And ultimately, you can mix and match these three components to really create the problems. James had touched on some of the previous slides, and Brennan did an excellent job of expanding upon, I love the lab AI example. Those are yet additional domains that we're now asking cybersecurity responders to be at least conversant, if not expert in. Playing that catch-up game, and James had touched on it in his earlier slides. So we're continuing to ask more and more of our people, and frankly, it's often falling on the shoulders of the cybersecurity analysts to be these broad subject domain experts, so that as new applications are being launched, the expectation is just, well, the security team is going to, in some cases, help me deploy these applications and monitor them, which falls far outside of what the primary intent of the team is. Additionally, as organizations continue to become more and more hybrid and to layer in these newer capabilities, organizationally, we're not keeping pace with technology. Meaning we have organizational structures in place which have very rigid boundaries. So it's not unusual for me to be talking to networking teams who have partner teams specific around cloud infrastructure. They do not interact in any meaningful way. Who here thinks that attackers honor the organizational structures that we put in place? Yeah, thank you. The chuckle is the only answer I need there. And just a couple of examples of the types of attacks that are occurring and the speed at which they're occurring. Specifically, even targeting, the use of AI, we'll talk about this in a couple more slides, but even the AI systems themselves becoming targets. James used the example of slop squatting. That's just one example. Generative AI systems that are being employed within the enterprise, they're productivity enhancers, ideally, right? Hey, help me, some of the examples James used, summarize the meeting I was just in, help me draft up an email that hits all the salient points of the project that I'm working on, making sure that we're keeping ourselves on task. I gain access into your compromised identity. There is one or more AI systems deployed within the environment. For all intents and purposes, I am you. I can't trick that AI into giving me your password or the passwords of your colleagues. What I can have it do is say, hey, summarize for me who I most recently interacted with over the last month. And it builds for me a map very quickly, organically and socially, as to where I might want to go and target additional vectors for attack, leveraging social engineering campaigns, things of that nature. So, it's not to demonize AI, but it's just to acknowledge the fact that it is a productivity enhancer on both sides of the fence. And in some cases, I think, offensively, it's still a little bit asymmetric in nature in the sense that, again, they can spray and pray all day long. And we only have so much time and endurance as humans available to us. So specifically here, AI becoming yet another portion. While it is a productivity enhancer, it becomes yet another surface from that threat landscape perspective. We're still in the let's talk about all the problems phase of the presentation. As a security vendor, I'll be the first to admit that I think in general, I don't know, as you walked around the show floor, security vendors are kind of exacerbating this problem in pushing this idea that, hey, I've traditionally done X for you. I've now introduced a large language model so that you can do natural language processing into the mix. So I'm now a security AI company. I don't know that that's true. And in fact, just bolting an LLM on top of an existing solution isn't fundamentally making it more efficient, more secure, or anything of that nature. But unfortunately, what it does do is it creates a ton of noise out there in the landscape for you all to have to try and sift through and meaningfully discern, what is actually providing actionable value versus just more marketing buzz and hype. Brendan touched upon we're basically back to where we were 12 years ago. I'm old enough to have remembered before cloud, it was service-oriented architecture, and then cloud, and now AI.
Remember voice over IP?
Right.
IPv6, yeah, the list goes on.
Well, we'll get to IPv6. I think that's going to come around any day now. Tomorrow, absolutely. I think fundamentally, too, part of the problem is because of that noisiness out there in the space within industry, there's almost become kind of this mental leap for a lot of people to just assume when we hear the term AI that we're automatically talking about generative AI, generative pre-trained transformers, large language models. That is a subset of a much broader category of artificial intelligence and machine learning. And I just in conversations with multiple DoD organizations over the last I didn't introduce myself either, but I've been with Vectra AI for 4 years. In the course of those 4 years, I have plenty of conversations. The DoD has done a phenomenal job for the last, almost 10 plus years of collecting data, building big data platforms. And there's nothing wrong with that. The thesis is sound. If we have all of the data, then surely that is inclusive of any bad data that we may need to be able to recognize. The problem becomes, back to that data plus time plus cost. Do we have the time to go back through all of that data? How long does it take to arrive at the data that we actually need to find? Do we know what it is that we need to find? Signature systems, that's great. I have a fingerprint for what it is that I need to search for. How do I find the next 0 day that nobody's published a CVE for? I've got all the data. Doesn't help me in that case. And then fundamentally now we're sitting there and saying, well, we built these big data lakes, so let's slop a couple of LLMs on top of it and we'll just query it and tell us to find all of the bad things resident to it. That's what you get with that approach. One, did you in fact truly collect all of the data? Did you collect the data in such a way as that you can extract that meaningful adversarial signal contained within that data? Or are you just sifting through mountains and mountains of garbage? I kind of touched on it. There's lots and lots of forms of AI. And ultimately, cut to the chase, a true AI-enabled cybersecurity platform needs to leverage all of the different approaches. So the title of the slide here the title of the presentation was leveraging expert systems to find what you didn't know what you were looking for. And that's where it becomes really important. You can leverage things like generative AI, discriminative AI, anomaly and baseline detection. Anomaly and baseline detection I'm going to pick on in a couple more slides here. But without putting something that understands, James had a good chart that talked about understanding the organizational structure and values important to the different people within the organization, how they interact with this data. If you don't have some type of expert system front-ending all of this, it's just yet more noise that you're going to have to sift through or manually tune and train yourself. And again, that doesn't fundamentally help you stop the attack that is being launched as I'm saying this in real time. With something that doesn't have a fingerprint, that doesn't have a hash, that has never previously been observed. And that, through those toolkits that I mentioned, that's only going to proliferate. So picking on anomaly detection a little bit more, and it is technically a field within machine learning. But this math-led approach of just doing statistical anomaly and analysis, fundamentally, what I've done there is I've given you a whole lot of different, which I'm now going to ask you to create a set of statistical rule sets to start to try and condense down to determine the bad within that different. Different isn't inherently bad. Similarly, I can't say that what has normally gone on is necessarily good. We've had, unfortunately, cases of insider actors where they're granted privilege to touch and access the systems and the data they're accessing. They then choose to do nefarious things with that data, exfiltrate it, send it to other actors, things of that nature. That's certainly not good. But the fact that they were doing it low and slow for a number of years, it's not going to trip one of those anomaly-based detection systems. So fundamentally, kind of turning the model on its head by 180 degrees, if you can start to build a set of systems that understand what bad looks like from the onset. So James had the slide that talked about the security researchers, sharing the TTPs, the tactics, techniques, and procedures that are being used across the different domains of network, identity, cloud, even AI, and define what bad looks like, hand that over to people that are expert in crafting the right types of algorithms across those broad subsets of artificial intelligence and machine learning. Now, all of a sudden, I know I'm not looking for what's different. I'm showing you what is bad within your environment and tamping down on a lot of the noise associated with what is different, what different looks like. Generally speaking, there's this idea of the no free lunch theorem, meaning I can't just create a set of general purpose models that are applicable to every use case. What I have to do is craft specific algorithms that are looking for things that are indicative of reconnaissance. I'm creating another set of models that are looking for characteristics indicative of lateral movement, of privilege escalation, of all the different phases of the cyber kill chain that align to MITRE ATT&CK, things of that nature. And what that looks like in this case, so I'll give a real world example here, of we built a recursive neural network. It was trained with millions and millions of labeled data sets that's able to discriminate between what is on the left, encrypted beaconing, which has legitimate use cases within environments. It looks incredibly similar, sub 1 percentile differences of encrypted command and control. But there are enough variations in the client server model, they get flipped on their head in the case of some external adversary commanding an infected endpoint. A recursive neural network is really great for being able to differentiate between what is ostensibly the same type of signal. So think things like cobalt strike, sliver, et cetera. So being able to suss that out without sending you just, hey, this looks like a beacon, this looks like a beacon, this looks like a beacon, and just causing you more and more trouble. Just to give you a couple of real world examples across those multiple domains, like when I mentioned that the amount of data that's being presented to us is only growing exponentially because we've got sophisticated attacks recently observed like Scattered Spider, where we've got compromised identity, pivoting through network, moving into cloud, and ultimately, not having any kind of care for the organizational boundaries we may have thrown up that allowed them to go undetected for many, many instances, subverting traditional security tooling. Additionally, Volt Typhoon, primarily a network-focused type of attack, but we know now that the Typhoons have been embedded in a number of critical systems. Again, totally subverting the more, I would call them traditional reactive, forensic, perimeter-focused types of tools without weaponizing the network itself. And even when you weaponize the network itself, we didn't have enough people to look at the signal generated from it to begin with. So how do we try and sorry, I spent probably 15 minutes talking about what stinks, what's bad about that. That's really the thesis for why Vectra has been doing, like I said, every company that you're going to talk to at the show and any show moving forward is an AI company of some sort. We've been doing this for over 13 years. The primary thesis being, even in traditional just enterprise networks, setting aside federated identity providers, setting aside SaaS platforms, setting aside containerized environments like Brennan had built up in his presentation, there was too much data with too few people, with too little time to meaningfully interact with it. But it's a perfect use case if I can continuously observe the actions and interactions of all of the systems, identities, and services interacting with one another across a network. Again, looking via these very specialized types of algorithms for these characteristics indicative of adversarial behavior. I now have a tireless, completely objective observer that's going to sit there and triangulate the particular activities, regardless of gulfs of time, because the motivated nation states, motivated adversaries, time and money mean nothing to them. They have an objective. In some cases, they've already achieved it. They'll continue to attempt to achieve it. And they're going to go as low and slow as possible. They're going to use living off the land techniques that will subvert all of the traditional tooling that's been deployed to date. But when you weaponize the network, when you turn it into a set of living tripwires, using those different categories of AI and ML to detect those different characteristics. So in this case, I gave the example of that recursive neural network. That's indicative of that 65% of the platform leveraging pre-trained or supervised AI and ML, meaning the minute Vectra is observing network traffic, we begin to fire those detections. The remaining percentage of the platform is using what's called local learning or unsupervised models, which continue to train and retrain themselves, constantly moving to the right with built-in periods of decay of the interactions. Think things like escalation of privilege, building a concept of observed executed privilege, and how that interrelates to the systems in which those identities are observed interacting with on the network in real time, constantly moving to the right, anchoring those I'll share that in a couple of slides, but just monitoring continuously the network and then prioritizing for the incident responders and analysts, what do you need to look at within the environment? Not do I need to go and look at 29,000 plus events, but hey, I need to go and look at 5, whether they're systems or identities. That's the dramatic reduction in workload by building a casebook of an investigation and presenting it to an analyst when they log in. And whether they're interacting with that information out of a SIM, out of the particular UI, through a series of API-connected tool chains that we build, doesn't matter. But providing all of the number crunching, the data curation that James had talked about, and prioritizing for you what makes the most sense to go and investigate right now. Those 5 things from a critical perspective. Hopefully all 5 of them are benign, and that just shortens the OODA loop for you to determine, okay, you know what, I'm gonna triage those things out. And that allows me to then move into those 11 that are within high, and then opportunistically hunt within the 207 low incidents. But as I was already saying, there are too few people having to keep abreast of the myriad of different attack surfaces, even as the MITRE attack frameworks, things of that nature, continue to evolve. You can't rely on separate tools provided by separate vendors. And I'm not trying to pick on any cloud providers, but I mean, like Microsoft as an example, there's been multiple exploits that are already aimed at subverting Copilot. The SharePoint breach that was just released last month. Those things are only going to continue to expand. So not going detection by detection by detection across whatever the different surfaces are, but starting with a prioritized view of, hey, this is the particular system. These are the observed detections, how they relate to one another. This is how I'm joining an already in progress investigation without having to do all that low-level data collection and correlation and contextualization myself. That is the real value proposition of using a true security-led AI and ML tool. I guess I already talked about hybrid cloud or cloud. Can't do a buzzword bingo without, and I'm from an AI company. So also from a zero trust perspective, how do you tie these sorts of things together? We receive telemetry. This is actually a logical depiction of how we are deployed in partnership with both Keysight and Cribl at an intelligence agency, where we're getting the packet telemetry. In our case, we don't have to do any kind of break and inspect on the packets being fed to us by Keysight. We're interrogating all of that network telemetry through our platform. We're then creating data pipelines of the post-process enriched metadata, as well as the detection information by way of the partnership with Cribl for that particular agency to, again, push what's most important to their analysts, to their cert floor, and to allow them to respond, and in some cases pull back. They'll do a subsampling of that metadata without having to force it all into a SIM, but then maybe leverage a more cost-efficient S3 bucket type of storage to pull back doing replays with Cribl's capability. So, hopefully it doesn't look overly complex, but the workflow in terms of the ingestion by way of Keysight, interrogating that data with Vectra, and then operationalizing it with Cribl is something that's already being done today. So this is not like theoretical or, hey, it would be neat if this was done. This is literally how it's done. And with that, I thank you all for the time. Looking forward to the panel portion of it. And if you have the opportunity to, please come by and see us. We're at booth T27, which is by the B3 Omaha entrance into the show floor. I think that's what we're nearest to. But yeah, thank you again. Appreciate it.
Thank you very much. Appreciate it, everybody. Hope you picked up on some of the important skill sets there that Vectra AI was telling us about, that Zach was telling us about. Next, we have Josh. from Cribl. Josh, come on up here, and we have insights about exactly what can be done with those data pipelines. Josh?
All right, good afternoon, everybody. Just going to start with a quick introduction to myself, introduction to Cribl, what we do and how we fit into all this. I know now that I can at most be the fourth smartest person in this room following these three gentlemen here. But without further ado, my name is Josh Brunval. I have been with Cribl for 10 months now. I am very familiar with the data realm. I was a former Splunk engineer. I did federal contracting for 7 years before contracting is contracting in this day and age, and decided to make the jump. So super excited to be here. My background is like I said, with a lot of data. The last 5 years I spent it with a use case I don't wish upon anybody, but it was tied into federal law enforcement. So we're taking subpoenas, warrants, PRTTs, working with partners from all over the world, local law enforcement, and trying to get some indictments, disruptions, protecting the people. So let me move on. All right, so Cribl in a nutshell. How many people resonate with this slide? And you can kind of change the data growth with how much time you need to spend to start to tame them. I would assume that it's safe to say at least 75% of you either have to wrangle a lot of data with a lot less resources than were given than the previous year, and not much options are out there. Not many options are out there to kind of address that problem. So about 7 years ago, our founders, they're actually from Cribl or Splunk proper. They came up with this idea and said, "Hey, we got to solve this problem." They left Splunk because Splunk said, "No, our bottom line is getting data in, and if we start to reduce that, that's going to cut into our margins." So they left. They created a company, and for the most part, this is an excellent tool to pair with and partner with Splunk. So it was very important to them to maintain that relationship and grow both those technologies together. Let me move on. All right. Oh, go ahead.
Just a little bit closer to the mic. I'm not hearing you too well.
All right. Is this a little better? Okay. Okay. So kind of the challenges in today's world, right? We just talked about how much data is out there, the verbosity, the variance, and just the variation of data that changes every single day. It is very draining on every one of the analysts, every one of the data scientists, whoever is in charge of maintaining and manipulating that data to make it addressable, scalable into whatever current systems that are out there. So that's not even including, hey, we got to make sure this data is compliant. That's not necessarily including that, oh, we got to make sure that these tools can work together and promote a level of interoperability. So Cribl has kind of identified a market where we're able to link your sources into destinations, sources being something like a syslog. If it's coming right off a file system, you're listening to TCP or regular UDP protocols, S3 buckets, you name it. Cribl is going to be there right in the middle to listen for those sources and then send it right to those destinations in a supported fashion. So weirdly enough, there are use cases out there for interoperability that I was blessed with working, where I had to have Splunk and Elastic and some cloud capabilities all be able to talk and leverage the same exact data stream. Unfortunately, it's very difficult to do that if you're relying on each individual tool as its own endpoint of the data. And then you end up creating N number of ways to process, parse, and handle that data and hand it off in an appropriate way where it can then be used later. So that's kind of what I just explained here. So right now, the costs are mounting up with all these different tools that are there for a unique purpose, right? I'm going to be the first one to admit there is a right and a wrong tool for every job, all right? I don't expect anyone to use a hammer to sink nails into a block of wood. So we want to make sure that we're using the right tool. And with that, The right data needs to go into the right platform. Not all data needs to be thrown into the same system to then be leveraged. And then, like you were saying, Zach, over the last 15 years, everyone's just throwing it in the same place, right? And that was the common practice. But unfortunately, that is starting to starting to teeter. So kind of what got us to 2025 isn't going to get us to 2035. So we want to create a framework, a data tiering strategy where we're able to collect from any type of source in an agnostic fashion. And then go ahead and do the actions and perform the enrichments. Make sure the transformation is appropriate and correct for wherever you need to send it. Or you need to send multiple copies to multiple destinations. If you're wanting to make sure you have a full fidelity S3 copy that you can go back and replay whenever you need it for compliance reasons, or you have multiple teams and mission sets that want to have a handle on a similar data stream, but they use it uniquely compared to each other. So each of these teams can leverage the same data streams and not have any worries of stomping on each other. So we have a proven track record in the federal space. So these are just a few of our customers that have been trusting us over the last 7 years. I'm very fortunate to be supporting that federal team, and a couple of my folks are on here as well. But lots of them are there to provide references as well, and they maintain very, very large infrastructures that we fit into in a way that is not disruptive. So, for instance, Cribl is a tool that doesn't demand you have to rip and replace any of your downstream ways to collect data. We fit right in, and you can pass that data through us, and we can kind of broker that. So I did hit on some of these kind of high-level topics here, right? First and foremost, data sucks, right? It's growing. It's not being addressed efficiently all the way yet. Throw in some now AI use cases where if we don't have good data and it's too voluminous and we know it's just garbage, right? We're going to have that Wall-E example, right? It's going to do us more harm than good. The second thing, right, I was talking about some interoperability in the federal use case the federal law enforcement use case that I used to be a part of. It was imperative to use the right tool, right? It really kept analysts, right? They wanted to use the tools that they're familiar with, gave them the opportunity to see other tools in parallel against the same data so that they can then learn different platforms. Most importantly, the vendor lock-in equation. At the end of the day, it's your data, it's the customer's data, right? So what is a tool to say that it's got to be in our format in order to search it? Or if you're trying to retrieve data out of a system you've already ingested it in, how difficult is it to pull it out, right? So we wanted to keep something in the back pocket of these analysts, these users, these folks that are in charge of these systems where they can go back in time, get that full fidelity data, and be able to use it down the road. Now, what it actually did with on the operational side, my biggest thing is when I was on site for 5 years with that law enforcement agency, I actually got back 20 hours in my week. Now, this wasn't an AI revolution, right? That the level of efficiency gain seems like it would be something like that was introduced. Cribl is not an AI company. We are there to empower some of those transformations that agencies and different organizations are moving toward. And we also are very kind of flexible with where we're able to install. We can be in the tactical edge. We do have some very lightweight agents that you can deploy, but we can also utilize the infrastructure that's already in place, that's already proven to be working and successful for you. And most importantly, reducing that time to action. I said it saved me 20 hours a week, but what about the analyst? What about the person that's actually doing the querying and doing the hard work to get those disruptions, right? I was able to, just as a quick fact, reduce all of my query times and across 3 different analytical platforms by over 90% just because I got rid of the pure garbage. I was able to enhance the data that went into those tools that were meant for that to be there. And I was a one-man show supporting over 3,000 people across thousands of cases. I did have help toward the end of my tenure there, and it's still running today, thankfully. But most importantly, right, it's the people who are accessing that data who can then turn that data into action and then carry on with the mission. I want to be fast because I'm super excited about the panel and conversing with you guys. But we're over at booth T6, actually across the street from Vectra over there. Information for reaching out to any one of us. Just wanted to have that plug there for you guys. But thank you very much.
Thank you. Well, folks, now is the time. Now is the time for the panel. So if you folks can all enchannel with yourselves, that sounds like a verb there. Let me get up to the microphone. So we're going to start the panel next. So folks online, I guess we'll have to, I don't know if we can point the microphone at the panel, but folks, get your questions ready to go. One of my first questions, and I'm going to go sit over here while this question is asked. I have two broad questions. The first one, the term decryption was used a lot, right? Well, now I'll tell a quick story. The FBI, there was a particular terrorist attack a few years ago. The FBI said, hey, we can't get into these terrorist iPhones that were left behind. Apple wouldn't help, okay? But I often hear vendors talking about decryption. They can decrypt the packets. How do you go about doing that without the vendor's approval or what have you? How does that work? Or am I asking a really silly question there? I'm curious about the idea of decryption. Because if we can get that to get real visibility into data, and if AI can make decisions on decrypted data, how does that work? Who wants to handle that question?
Or with it, do I push the button? There we go. Yep, I can definitely start with that. So
Okay.
When we bring up mostly decryption from like doing network detections, it's about the traffic flows themselves. Right?
Okay.
And those are generally, encryption is good, is the first thing on the impact, and then very necessary from a perspective of compliance. But the idea is you need to participate with that network flow to, rather than necessarily decrypt, to encrypt in all directions where we see it natively, but any bad actor on the network, anyone looking to get data they're not supposed to, just sees the garbage that is random characters and network flows. Right now, if that's all you see is wingdings, essentially, good luck creating an algorithm that can see the negative messaging or the data that you didn't want to leave the environment, or the nefarious API call, right? You've got to have that in a decrypted format, but just as importantly, it has to also be encrypted on its way out or through other areas of the network in a defensible manner. So that's where you get into like post-quantum cryptology and things like that. We need things to be encrypted, but what that has done is raise the burden on tools and inspection processes to see it. Because you can't just encrypt end to end and then just have a key somewhere to spin it back off and look over the traffic.
Can I add one thing to that? And it's not contradictory to what Brendan said, but if we think about the use case of a bad actor on the network, either insider who wants to obfuscate what it is that they're doing, or external nation state, what have you, the participatory decryption that he's discussing, that is good when we're talking about approved and above board communications. But when you're talking about a bad actor who's most likely rolling their own crypto, you don't have the benefit of being able to look inside, to look for those payloads, to look specifically at those underlying, what is in the packet itself. So that's where training specific models to look at interactions of systems. So yeah, you don't have the benefit of at first glance knowing what that immediate payload is, but if I can detect the type of behavior being exhibited, that's at least enough to make that next step of, okay, I need to isolate this system, I need to black hole this user, blacklist this domain, things of that nature. So there, again, it's not contradictory to his statement, but just food for thought for thinking about the different use cases here, because cryptography has multiple roles to play depending upon who's employing it.
Anything else to add to that, sir?
No, I think that falls in the category of obfuscation, of course, as well, right? They don't
okay.
want you to see their actions any more than we want, a foreign actor to see ours.
Thank you very much. So, my second broad question is, and it's something that is constantly discussed, and I want to hear it from three industry workers. Are we going to need cybersecurity workers in the future? And I know that's an awfully broad question, so I'm going to say it more specifically. What are some of the killer skills that in an AI-enabled world these folks need to pick up on? Fair enough? All right.
So, who here has trusted end-to-end what AI has output, whatever you put in? I don't either. I don't either. Sometimes it's entertaining what it gives you, and it's kind of reassuring, at least for me, that I know I'll have a job tomorrow.
I will say this, though. A lot of people are saying that AI is getting exponentially smarter. Last year,
100%.
it said really dumb things. Now it says smarter things. So.
Agreed. But it is still something to check, and as of today, I think tomorrow I will have a job. But down the road, once we have different workflows and processes that are going to be more standardized with how we're doing threat detection, like some of the big ticket items where, let's just bring it to law enforcement, right? We have particular techniques and procedures to go through, follow legal procedures to kind of deliver, right? What was asked of us. It will be disruptive and to a point where it will be more, I think, helpful than replacing. We're dealing with a lot on the side where we're in high side environments. I think they're already on a struggling kind of workload of people filling roles. So I think that the folks that are on kind of like that NatSec side, they'll be able to maintain that much longer than, let's say, a company that's doing something kind of in the open and I'll just say unclassified side, but it's a public facing side. I'm very curious what next year brings with the different tools. What's going to come up? Like I said, Cribl isn't an AI company. However, we are incorporating a lot of AI-based tooling. So we have different sets that are going to be automatically able to prevent data drift, right? Some of the biggest things is when you have different sources that you're used to collecting on a regular basis, and then all of a sudden it just changed. Whether that's a formatting thing, a version control thing that wasn't made, you weren't aware of, that thing pops up all the time, and at least it did all the time when we would subpoena, companies. It was different the next day that we did it, last week. So that would always be a problem that would rear its head into my realm. But we also have some tools that, we want to kind of make it easier for the analyst to use. All right, we want to not become a tool where you have to have a huge skill gap to overcome. So I think it's going to be also a bit of a crutch first, so that people can get up to speed, learn how different techniques to onboard data, ingest it into particular platforms, and create pipelines to manipulate data for whatever that use case is. So,
Brendan, what did you find? Thank you very much, Brendan.
Yeah, I guess my perspective would be, Microsoft Word, for instance, didn't remove the need for knowledge workers in a workplace, right, in an office, but you'd be hard-pressed to find pretty much any role around an office that needs to organize things where people don't need to know how to work an Excel spreadsheet and Word, right, and basic typing skills. So I would think kind of along with that, right, it's very quickly getting to the point where you need to know your tools, and you've always needed to know your tools, and you've always needed to train on your tools. I think AI-enabled applications and existing tools we already have that have already started to incorporate a lot of these things, we do need to be aware of and know about, right? Because that does have an immediate impact on the day-to-day, right? A ticket management system, some of the largest ones in the world have already started embedding AI automated response components, things that'll alter tickets, those kind of things. If I am managing the operations of a service desk and that tool escaped my knowledge of being there, it would be very confusing and hard to understand how to resolve some data pathway or some operational issue with it if I didn't understand or rationalize what the AI was and wasn't doing to it.
Yeah, I think a couple things just to keep in mind. Today, at least for today, any of the things when we talk about AI, we're not talking about cognition. These systems don't think. They inference. You've heard the terms hallucinate, things like that. So they can be very, very good at producing what seem like largely reasonable outputs, but it is not independent thought. There's cases where in the commercial world anyway, AI has been turned over to handle rollout to production systems and deleted entire databases. So I think we're still going to need the human in the loop. I think it will be an up-leveler in terms of providing more time, hopefully more time. And I think, James asked specifically about skill sets. The one recommendation I would make is if you're able to, avail yourselves to more of the offensive side of things. The more and more you can stay abreast of how attackers are behaving, leveraging multiple tools that you've got within your various disciplines from a defensive perspective is only going to make you that much better in thinking about, regardless of whether you have the advantage of any kind of AI-enabled defensive capabilities or not, just you being able to fundamentally understand what is the low-hanging fruit and how they will then try and attempt to move post-compromise. That would be my biggest recommendation.
So look for bad behavior techniques.
Acknowledge your weak spots. Think about, just try and put yourselves in the role of what an attack, how, if I wanted to circumvent and you have the insider's advantage. You know how your systems are enabled. Not everybody has the benefit of participating on red teams as pen testers, but really try and put yourselves into the role of somebody who wanted to do harm or extract sensitive information from the systems that you're meant to protect. At the very least, it gives you a good place to start investigations and for where you would look.
Thank you very much for those answers. Specific questions from the audience, either online or people in the audience. Do you have any questions about particular skill sets that you're interested in or about the impact of AI, for example, on specific job roles? We'd love to hear your questions. If you have a question, I think we have a microphone hanging around here somewhere. I don't know, Ashoka, is there one? There we go. We have a question over here. See if we can get a mic on over to you. Thank you, Jackie.
Check. All right, there we go. So being leaders in the industry, what do you guys think is kind of the balance that, especially people who are utilizing AI in the tech field, what's the balance of usage versus learning how to do it yourself and then using AI to kind of augment your productivity and output? What's the balance you guys have found that is healthy and productive for the user?
Yeah, I absolutely love that question. So I do think it leans a lot more towards needing to be more theoretical with your knowledge base of it, right? The idea that you do not need to know how to build, manufacture, or even really relatively maintain an automobile to operate it is a pretty strong one, right? It's kind of similar to that in my thought process. The idea that I can be classically trained as a computer scientist, understand programming from theoretical down to the conceptual component of it, but I can use AI to allow me to do what I'm trying to do in any scripting language I'm trying to apply it to over the weekend, right? Without needing to completely wholesale learn the new language because I've got enough knowledge of how languages work and what that looks like. But I would say going forward and now, you don't necessarily need a full-skilled computer developer that knows how to do assembly language coding unless you need to be looking at assembly code, like defensively or something like that, right? And then they need to be able to get into it and get it when the interpretations come through, right? AI will make a detection that says there's something wrong here. You will need someone that knows that to specialize in it. But if all you're asking for it is, I don't want Python today, I want Golang today, I should be able to say, okay, Claude, give me the reasonable approximation of what I did here in this language, and then I can work through the bugs myself much quicker than trying to write it from the beginning or going to the library and getting a couple of books like we would have done at one point to learn a whole brand new programming language. So I do think it is very much going to get to that 90-10 perspective where you really don't have to have ownership over the final deliverable to that extent, but you do need to understand what it's doing and where it's going to misstep and watch for it.
This might seem like a trite response, but just generally, I really love the way you frame the question of like, what is a healthy versus unhealthy sort of balance of where you would employ these. If the time it takes you to do the thing, in terms of prompting and recrafting prompting and recrafting the output and editing the output, maybe consider just doing it the old-fashioned way. And I don't mean that as trite, but just I can't tell you the number of times that I see people, spinning their wheels on interacting with this new system. By the way, the amount of energy and like the ecological impact of doing it that way versus just doing it the old-fashioned way is not insignificant. So I just have a willingness to still do the manual work when it makes sense, but by all means, like the example Brendan gave, I mean, there's tons of great use cases where, hey, I'm cooperating with this in a certain way. I'm still going to have to work with the outputs a bit, but just like be, I guess, just honest upfront about the time I'm looking to invest in doing this particular task. If I could just do it and be done, great. Now, if it's something that you then plan to do repetitively, hey, is there a framework that I can create that allows me to then handle that type of thing over and over repetitively? Great, that's awesome. But just be cognizant of those discrepancies.
Yeah, that was the golden rule of automation, right? Don't automate something you do once, right?
Let me ask a question about GRC, about the idea of compliance. We can call it what have you. Has that become a more important skill set with the advent of AI, or with the advent of what you are doing in terms of, when I say what you are doing, what your three companies are doing to help implement observability? Is that a skill set these folks ought to think about?
I think I was actually having a conversation down on the show floor earlier, specifically around the artifacts to support the expected controls implemented across systems, and the efficiencies gained by looking at the outputs of the platform that Vectra provides, because it's constantly monitoring and providing you all of the supporting artifacts of all of the observed traffic. So when we talk about things like GRC, having a under the auspices of continuous monitoring, having a live system of record that I can go and query at any time to look at the state versus point-in-time inspection. I'm not quite answering your question, James. I mean, again, I think if your subject matter expertise lends itself to looking at or performing those types of GRC-related activities, there's ways to enhance that, and I think there are efficiencies to be gained there by employing AI. I think also, both of the other co-panelists represent technologies that also assist in that.
So I am not familiar with the GRC acronym.
Oh, governance.
Oh, okay. All right, I am. I've been so head in the sand with a lot of the work that I was doing. So yes, so a lot of the compliance, unfortunate expertise that comes from is a lot on the legal side of how are you maintaining data? How can you ensure that if you are able to legally present it in court, did you collect it appropriately? How are you going to maintain each and every one of those artifacts? There is a chain of custody, right? Are you dealing with evidentiary copies? I think if you are going to implement a strategy where you can maintain that at any point where the data is referenced, I think that's your CYA. But if you have some kind of, I think it's like vectorization of where you have like some metadata tags that are associated in data where you can reference later in some of the kind of like the AI chatbots. I think you can then kind of be a little bit more trusting. It's hard to say trusting, especially when you deal with legal. But I would say that it could be useful, but double check.
Let me ask you a question. I remember when in talking about observability and talking about the idea of, because you're talking about basically the systems that you can put in place, the three of you have the ability to really get right into the details and also understand context and things. How long does it take to implement these kinds of systems? The reason I'm asking is that when SIMs first became a big thing, 10 years ago, the discussion was it'd take about a year and a half to get one of those properly tuned up and working. And what you're talking about is something that it provides even more contextual information than a SIM, right? So how long does it take to get something like that going on a production level?
It doesn't finish. When we were doing SIMs back in the past, right, it was a largely static environment, right? You had your assets that you controlled. They were responsible for certain areas, certain types of data sources were available, and you had to wire it all up, and it was fairly like systematic through there. And hopefully by the time you got it deployed, they weren't going to change it all and do the forklift, right? But now there is no such thing as a forklift, right? We have resources that are available. They come, they go, they change, and that's where it comes into the enrichment side of things, right? If that doesn't match the requirements of some sort of inspection component or a compliance component or just human accessibility and readability, then you have to augment it. And you have to augment it once, hopefully, but you need to augment it the way the individual endpoints need them, and they're going to continue to change. So the biggest part of it, right, we largely exist in the plumbing of all of this. So we tend to be one of those that gets to see everybody sit around and wait for the different teams to come online and get the resources available. And then finally they get around to some tooling, and then we can start to pipeline things. That's great. And then the network changes, or AWS or Microsoft change some feature availability that comes out on Tuesday or some random day for the AWS case, right? The network is evolving, the edge is evolved, the components have evolved, the tools are all evolving. And the adversaries are all evolving. So the idea is we need the flexibility to not expect the one diagrammed go forward project that can then be implemented to the exact spec or not. It doesn't end.
Yeah, no, I mean, the, from a zero trust perspective, I would agree that it continues to move to the right and evolve. Yeah. But to give a very tactical example, so as represented by the three companies here, I mentioned, there are multiple use cases of the three of us working together to support particular agencies. I want to say the initial implementation of the three of us at that particular intelligence agency, again, data will continue to evolve and be added to it, but just the plumbing, as Brennan put it, was put in place in under a week, right? So we have packets being fed to Vectra by Keysight. We're producing detections, we're producing metadata. The initial pipelines, there can be additional augmentations, transformations created of that detection data as well as the associated metadata sent to Cribl before it ever hit the SIM in the example that I gave. And that literally continues to evolve to this day. That instantiation dates back over 2 years at this point from its initial inception and is still at play today. So just initially operationalizing it, in the grand scheme of things, comparing a year and a half to a week is,
See, that's fascinating. That to me, the speed of that kind of blows me away personally.
So you're talking about time it takes to build something. Like
Sure.
I can build a SIM in a day. Like I did that traveling for well over 7 years. It wasn't that hard. What was hard was dealing with unique customer requirements inside of their unique environments and their unique use cases. For me, I used tools that were never envisioned to be used in the way that they were. So it was, like you said, and the clock just kept getting reset every second, right? It was never a static use case, though kind of like that initial infrastructure.
What reset the clock often? Was it different user requirements?
Different user requirements, and then just different data. You're gonna have to go back and double check and make sure, like, why something changed. Why did something get this far in our data pipeline, our framework, that it just went belly up? Why did it do this? There's a lot of things that you can't really plan too far ahead for, because everything's going to be out of left field when you are at the whim of whoever created the data and gave it to you and used whatever transport for you to get it. So I think, the ever changing, the biggest variable is the data, how long it takes to get that onboarded and scalable, ready to be serviced.
Okay.
Yeah, so kind of an example of that is the local AI lab project of mine. Because of all the open source heavy nature of it, I got it up and online in a weekend, right? A wrapping around LLMs, having it write and interact with other API calls agentically after I ask it to do something, that type of a thing, right, in about a weekend. So the expectation is that we have to support different entities within our organizations in their goal to do something like that for their specific use case, but there's going to be thousands of them. So we need to be able to get our hooks into it to see exactly what it's doing. We need to have tools that can be already ready to look for the 0 days in an infrastructure we didn't know to look at last Tuesday. And then we have to be able to alter the data so that whatever it's interacting with can't see what it's not supposed to by compliance. Because if I built that app in my basement, I sure as heck wasn't confirming the compliance requirements before it went and asked all the data questions.
Thank you, thank you. Questions from the audience or, go ahead, Stephen.
Yeah, I've got a question from online, one of our online attendees. How can you apply AI to log review and data records auditing?
Good question.
So I'll address it at least specifically from the way in which we do this. One of the primary data sources, as I mentioned, was network telemetry, but we augment that through log ingestion. So specifically Windows event and log ingestion, as well as Active Directory, pulling DNS logs, things of that nature. And so it's a good question. It's kind of a broad question because depending upon what it is that you want to extract from those logs, there's any number of different approaches that one might take. But just to give a tactical example as to how Vectra employs log ingestion and transformation, interrogation, that's one of the ways that we do that. And specifically, we're doing that to look for things, and that's actually a portion of the unsupervised or local learning models that I referred to in my presentation. That's where some of those categories of detections are housed, are within those unsupervised or local learning models, because they continue to train themselves and discard the training sets as different actions are observed within those logs. We don't forget what has been observed, but in terms of what the models are using to train themselves, continues to decay as they roll to the right. So that's important too, depending on what it is you're hoping to surface from those logs. But if we're looking at use of observed executed privilege and potentially abuse of executed privilege, having that built-in period of decay and using those log sources as the local data set upon which to train them is pretty critical.
Right, but then I'd say you need a little bit more complexity in there on top of it, right? So you need a platform like that that's doing it in a couple different ways to then normalize it to ultimately not be screaming every time something changes. Because if I point my within Windows OS system AI agent that's already there at a log data set, which is the how, right? It's very easy. The answer is you install something that wraps an LLM, you point it at it. You get an ML service and you point it at it. And the result of it can be all sorts of made up answers or screaming about some little component that it sees in that data set that will not be in any way, shape, or form relevant without a lot of guard rules and massaging and counterbalancing with other methodologies and that kind of thing.
Yeah, the guard rules was the example I mentioned of kind of putting an expert system in front of some of those other approaches. So like
guardrails or guard rules?
either both.
Yeah, but that's just the answer. You can do it very easily, and you can do it very easily badly, right? Again, you're missing the compliance, you're missing all of the care and feeding, you're missing the ongoing life cycle of the tool set, you're missing all the extra insecurities with the new systems that you just hodgepodge throw out there. You're missing all of the false positives, you're missing all of the alert fatigue, you're missing all of that without something that's a better designed system around that to actually give it to an analyst. And again, give them the 10% they need to care about what it's doing and then run with what they're supposed to actually be actioning on.
Thank you for that question, online person. Stephen, thank you. Additional questions, folks, and just so you know, we got about 5 minutes left. At that hour, there's another presentation starting about 8140 that we'll be doing. So we have to keep things pretty on key for that. So if you see me wrapping it up a few minutes before, that's because we have another session in the next hour. But questions that you have, folks, in regards to, say, skill sets or anything there? Yeah. Looks like we have a question over here. Thanks, Ashoka, for trundling that on over. And for those of you folks, any additional questions as well? Yes, sir.
Thanks. I just was wondering if your thoughts of what you've seen in industry with respect to integration of quantum computing in with AI and this.
He was asking about quantum computing. Thank you for asking that, because I was going to ask about that myself. Yeah.
Either as requirements based on the volume of data that you're getting and the different what-if scenarios you need to run on it, or as a differentiator to what you may be packaging up. Thank you.
Yeah, I might be a little bit of an outlier to this, but my perspective on it is they're totally different buzzwords and technologies, languages, right? It's kind of like the idea that it's not even a language in the same sense of languages, right? So there are a lot of different things and components around those types of initiatives. Quantum computing in general is a very cool thing. At Keysight even, it was pretty wild, but we spun up an entire division on it that took like 20-something PhDs and have like actual sellable part numbers and things that apply to quantum computers, right? Power supplies, monitors, meters, all sorts of cool things like that. Those are not the same thing as like wrapping LLMs or doing something in Kubernetes, right? It's just so night and day from the type of technologies. I think there's impact from quantum computing that I think has been like the boogeyman for a while, similar to the way the AI boogeyman's been kind of rearing its head. And I do think that it may at some point materialize. It could also just go the way of analog computing, right? So it'll be interesting to see where that goes for sure. But as of today, there is no like Ethernet connection to it that makes everything nefarious or scary from a defensive perspective. I will say the whole post-quantum encryption component can really impact this, right? Because again, that's a whole threat component of it. If you can predict in some way something that a system like that might do as well, there might be some cool, interesting timing things that could be done. We have a group that was a recent acquisition of Keysight called Rescure that does like side channel testing and training around like physical board manipulation and things like that. And they've been able to break and demonstrate at things like Black Hat post-quantum crypto technologies at like a hardware level, right? Looking for strange little electrons and things like that. Again, very different surface level than what is today's AI products, right?
I'll add this. I just did a webinar for BAE Systems about post-quantum. And, you know, in 2030, about 5 years from now, you've got the idea that they want to have RSA, that algorithm, Diffie-Hellman, that algorithm, replaced. And NIST has already come up with replacements. But the question will become, for example, on the decryption side, you'll be updating your products to do that, for example. And also, you know, certificates, independent of post-quantum, certificate life has been greatly shortened. I think the ultimate life right now is about 296 days. Most banks have it at about, I think about 130 days, the life of a certificate. You're going to see that shortened over the years to like, I can't remember the exact, it's about just over a month. Yeah. Oh, it's like a month, like 36 days or something. So you're going to see all those kinds of changes specifically happening. By 2035, the RSA and the Diffie-Hellman that we all know and love will be completely, have to be replaced, because as quantum does become a reality, it'll be democratized to defeat that stuff.
And I think that is kind of the PhD predictors. Right. It's math and theory at this point, right? But Y2K did not crash everything, and we did not lose our society as we know of it today. So that's my one caution to a lot of that. It is very much for me in that boogeyman cloud when some of that kind of materializes. I come right back to a lot of that around some of the AI fears. Right. It is not a thinking, rationalizing being. It is a mixture of really cool, odd technologies, some that are more understood than others.
Final thoughts before we, final questions, first of all, before we end, and final thoughts here. Question right here. Thanks, Ashok.
So I'm not entirely sure how to word this question, but I'll do my best. In the context of a small team focused on offensive cyber operations, and the nature of the job requires very segmented. The data set needs to be very, we'll just say segmented. And the team, we don't have a lot of experience with AI, but we would like to because we use a lot of data, we get a lot of data, and we can't, we don't have the ability to acquire people easily. What kind of advice would you have to people who want to utilize AI data to use AI to analyze that data better? So the team is small, we have a lot of data. How could we utilize AI as beginners? Just analyze that data better. That was a lot, I'm sorry.
Yeah, what advice do you have about using AI data, using data better using AI?
Yeah, as to complete beginners.
Sure.
In terms of AI, where would you start? If you're a beginner that needs to process a lot of data to a small team, and we can't exactly just go out and hire or go out and use software, just the nature of the job. DoD agency, I'll leave it at that.
So as someone that was represented by themselves and maybe at most 2 people, we had 3 people in charge of a couple thousand folks to do lots of work against lots of data, lots of different stuff. I think it doesn't change if you want to plug in AI at whatever point, right? You want to just begin to understand what you're working with. Query the data itself, question itself, but do it first by you. Once you start to understand a little bit of the patterns and the differences with particular fields that are interesting to you, or maybe they pop up a lot, they just stick out, that's when you want to go, okay, now I want to go learn, why is that field important? What is that going to be telling me in terms of this data over a particular timeline? So first I would say just dive in yourself. Don't rely on AI just yet until you understand what the underlying, the intrinsic value of the data you're looking at is, and then start to have conversational. Assuming there's no, you're not up against a clock about stuff, right? Just keep it conversational. Be curious. Don't be afraid to mess up and just dive in.
Yeah, I like that a lot, right? Kind of flips it around. What would you do with that data, right? That's the big question, and that's kind of what you would want the AI to do. And I think that comes around to it, right? When we say AI, there is a lot that falls under that bucket of AI. Yeah. I think I would need to understand more about what you're trying to do with it, and then I would start looking for resources around technologies that would help automate or speed up or rationalize slightly different than the people do, that type of a thing. That way you're kind of looking for something to aid you in what you're already functional with doing with it. Yeah, but it's going to be about that, right? Otherwise, if you just point something at it, it's just noise, and it'll make its own patterns that won't be useful.
Yeah, and I can definitely respect, in this venue, there's only so much that can be said about, what it is that's trying to be achieved. And you did a good job of articulating it without going too far. If it's helpful, I'm happy to have, I'm green badged, so we could have a separate conversation about that maybe in a more appropriate venue for that. Because I think everything that's been said thus far, in terms of generalities, is applicable. But sometimes having the right conversation in the right place is also beneficial.
I think taking that offline would be a good thing. Yeah.
And if I step it back to just kind of more open end, what do you do if you've got a task you're trying to do, but you don't know what you could do, where the boundaries are, and you're brand new to it? Open source and research has really been churning on this stuff, right? We heard about new libraries that have already been released. I had, over the course of about 3 weeks of me getting that AI lab up and starting to show it off to people, there were a dozen, per individual container, which were all different open source teams, releases, within that time, that I had to update, curate, reapply, make sure I didn't have any mismatches, that kind of thing, right? It's very, very active. So you can very easily find Medium posts and blog posts and AI-generated posts and videos about the things that you can do about a specific generative or non-generative or ML or something like that type technology. And I think some of those have some pretty cool ideas, especially offensively, right? It'll frame itself as pen testing or for non-nefarious purposes, I promise. But when you really start to dig into it, you can see what some of those ideas are.
Thank you for that. Now the final question. So appreciate it. And, we have an AI Essentials course I could tell you about as well. That AI Essentials course is designed to help people feel comfortable with interacting. Most interaction with AI is frankly copying and pasting. That ain't interacting. So that's one of the first steps I would recommend is ask yourself what AI interaction really means. Thank you, folks, everybody, for attending this previous session about understanding observability and cybersecurity in the face of AI. Thank you, folks, for attending. Thank you, representatives from Cribl, from Keysight, and Vectra AI. So we do a big hand. Now, folks, starting, I'm going to have to say this at the 10 after, just a few minutes, I'm going to get things set up for Brian Correa to come on in. And Brian and I are going to be talking about 8140 in this current session, which is happening now. So thank you, guys. I appreciate it. And we're going to go ahead and take a few minutes to get our computer set up for the presentation. For those of you who want to key in for your continuing education credits, you can do so right there at the back. Thank you again, everyone.